Hello to you guys. Welcome to another exciting episode of Tenfold Life. My name is CBC, and I'm running parallel with myself to bring you another awesome and very informative edition of Analytical Geometry. This show is proudly brought to you by Liberty, and it comes to you every weekday, Monday until Thursday from 5 p.m. all the way up to 6 p.m. So do make sure that you always join us on this very exciting and very informative show. Remember, you are part of this show as well, and you actually dictate what happens in this show by sending us your questions on WhatsApp as well as on our Facebook line. But above this, you can also use our very awesome app, which can also allow you to stream the show live. This app is available on iOS as well as on Android. It is called Tenfold Education. It will help you gain access to awesome videos that will help you build your content from grade 10, grade 11, all the way until grade 12. It's just a very useful app that will help you to prepare yourself for exams. You can also use it to stream the show live and be part of what is going on here. Thank you very much for joining us. We are really looking forward to an awesome jam-packed show that will help us build our analytical geometry knowledge. This week, we're focusing on analytical geometry. So keep sending us your questions on analytical geometry if you want to. We will go to an insert video that will help us orientate ourselves to analytical geometry before we begin having fun with the actual content. So let's go check out this video.
Analytical geometry, also referred to as Cartesian or coordinate geometry. Analytical geometry uses algebraic methods to represent and solve geometry problems. The correspondence between geometric shapes and algebraic equations means we can convert geometric problems into equivalent algebraic problems and solve using algebraic methods. To be successful at analytical geometry, you will need to understand all of the work done up to grade 11 and, in addition, the concepts of equations of circles, equation of a tangent to a circle, and length of a tangent to a circle. In preparation for your exams, make sure to watch all of the analytical geometry videos and attempt all of the assessment equations at the end of the lessons. Once you have mastered those skills, the career video will take you beyond the classroom. Analytical geometry is roughly 40 plus minus 3 marks in the final exam, which is approximately 27% of Maths Paper 2.
Well, there you have it. That is analytical geometry in a nutshell. If you wanted to know what analytical geometry is about, what we are interested in, that video helps a lot in trying to give you just that introduction of what this whole concept is about, to give you a little orientation around what we are busy with. Remember, you can get this kind of video and even more of its kind on our app. Just download the Tenfold Education app. It will give you access to these videos. It will give you access to content as well, and a lot of very awesome stuff that is happening. So now it's time to have fun. Let us have fun. We are going to go to a question that was sent to us by Harold. Let's go and hear what Harold had to say.
Hello Tenfold, my name is Harold Mugangwe from Bumalanga. I have a question on analytic geometry. Can you please help me? Here is my question. Thank you.
Very interesting, very interesting indeed. Thank you for that question, Harold. It's a very nice analytical geometry question. It does involve a lot of what we do in grade 11 as opposed to being entirely grade 12. So if there are grade 11s watching the show, there's also a lot that you guys can benefit from this. Remember to also send your question if you want us to help you to analyze any challenging concept that you might be working with. We are here for you guys. We are here to assist you. A big shout out to Liberty for sponsoring our show. We are very grateful for them. Without them, we wouldn't be able to bring you this awesome show. Let's go and check out the question before we begin analyzing it. I want to look at it with you guys so that you can see when I start talking to you, what exactly am I talking about. If you look at this, it says to us there is a particular diagram that is sketched for us. It says in the diagram, there's a point A with no coordinates on it, point B with the coordinates -6 and -5, and there's another point C, which is 8 is to -4, are points in the Cartesian plane. F, 3 and 3.5, and G are points on the line AC. Those are points on the line AC. such that AF equals FG. So we are told that AF equals to FG. Right off the bat, when I look at this, there's something interesting that I can pick up from this sketch. Just without any waste of time, I can see that this point is basically the midpoint. I don't even know what the questions are going to be, but analyzing this actually helps a lot. This is the midpoint of the point A and the point G. I might need that somewhere along the way. All right, if you continue, we are told that E, there's a point E, which is basically the x-intercept of the line EB. That E lies exactly on the x-axis. If I look at it, I can actually even say that I don't know what the x-coordinate is at point E, but I'm definitely sure that the y-coordinate is going to be 0, because everywhere on the axis, the y value will always give us a value of 0. So now we are about to look at the actual questions. It's always important for you to analyze the love letter, the opening statement that you are given in geometry. It helps you to think clearly about what is going to happen in front of you, and then you can actually position yourself much nicer when you're about to answer the questions. So let's go and see what the actual questions were in this particular question. The first one that we are asked to do is to calculate the equation of AC in the form y equals mx plus c. So let's look at AC. AC is that line that passes through point F and point C. Remember, for you to find the equation of a straight line, you don't need a lot. You just need to find a gradient. If you've got a gradient and you've got a point, you can be able to find the equation of a line. Gradient is y2 minus y1 all over x2 minus x1. So I don't like the point that the fact that on point F our y coordinate is 3.5. I prefer writing it as 3 is to 7 over 2. 3.5 is the same as 7 over 2. So I'm going to use that instead. So my y values are the value there minus 4. There's minus 4 minus 7 over 2 divided by the x value is 8 minus 3, which when you simplify, you're basically going to have minus 8 over 4. Minus 8 over 2. Let's fix that to a 2. Yes, that's basically equivalent to 4. I'm trying to do it without wasting time. Divided by 8 minus 5 minus 3, which is basically equal to 5. If you simplify this, you are basically sitting with minus 15 over 2 times 1 over 5, which when you simplify further will just leave you with negative 3 over 2. That is the gradient that I have. Now with the gradient, I can now continue and say, since y is mx plus c, the y coordinate that we can use is either at F or at C. I'm going to take the point C. The y value is minus 4. The gradient is negative 3 over 2. And the x value that we're given here is 8 plus C. When you simplify this further, what will happen? Well, something simple emerges here. You're sitting with negative 4 equals to negative 12 plus C. And if you transpose negative 8 to the left-hand side, it's going to be positive, negative 12, you then have 8 equals to C, leaving you with the equation of y equals to minus 3 over 2x plus the value of 8. Very nice question indeed. It is asking us to find the equation of this particular line that we're dealing with. It's nice, not complicated at all. It will help you to be able to solve future questions. Remember, in geometry, all questions are lead-on questions. The first one is likely to help us to do the second one. So let's continue and see what the second question is asking us to do. The second question says to us, we need to calculate the coordinates of G. There you have it. So now we want to find the coordinates of this point G if the equation of BG is 7x minus 10y plus 8. So I'm looking at a point where two straight lines meet. The first one is 7x minus 10y equals 8. The second one is this one we found that says y is minus 3/2 x plus the value of 8. A very nice point indeed. If you look at this, it's not at all complicated. If you look at it, we just have to solve them simultaneously and try to figure out what the coordinates of G are going to be. Now, if you try to do that, I can just simply substitute my y as minus 3 over 2x plus 8 into the first equation. Let's see what we are going to end up with if you do this. So I'm left with 7x minus 10 into, I'm substituting that minus 3 over 2x plus 8 on the value of y equals 8. And if you simplify this further, what do you end up with? Well, this is going to be 7x. Minus times minus is going to be positive. The 10 divided by 2 is 5. If you multiply 5 and 3, you're basically going to end up with 15x minus 80 equals to 8. Let's see what will happen if you simplify further. This is 22x equals 80 to the right-hand side gives us 88. Our x value, when you divide both sides by 22, is simply going to give you a value of 4. Very nice x value that's not a fraction. So I'm always happy when I see numbers that are not fractions. So your x value is 4. We now need to find the corresponding y value. I can use any one of these equations that are given, either the first one or the second one. Let me try to use the easier one. I feel like this one is the one I'm going to use. So my y value is going to be negative 3 over 2 into the 4 that I got plus 8. Let's simplify this. Half of 4 is 2 minus 2 times this. We are simply going to get, let me see, 4 divided by 2 is 2. You have negative 6 plus 8. If you combine them, you end up with a y value of 2. So the coordinates of G are simply 4 is to 2. We will then go on to the next question, because this is a very nice question because it's got a lot of sub questions, but then they take a lot of our time. So we need to be careful with what we do here. Try to help you to understand at the same time without losing you guys. 4 is to 2 is the coordinates that we're dealing with here. 4 is to 2 is what I'm sitting with. The next question is asking us to show that the coordinates of A, we're given the coordinates of A there. We need to find what the coordinates of A are. Now, like I said here, F is the midpoint. So I'm going to apply the concept of the midpoint. According to our knowledge of the midpoint theorem or the midpoint formula, the x value of the midpoint is going to be x of A plus x of G divided by 2. If you simplify this further, the x value of the midpoint is 3. It's 3 there, which is F. So 3 equals to the x value of A. We don't know what that is, but we know that the x value of G is 4 divided by 2. Cross multiplication, 2 times 3 gives us 6 is x of A plus 4. If you transpose, you're going to get 2 is x of A. Very nice and simple, not complicated at all. And then the y coordinate, we are going to do the same thing again for the y value of A. Y value of the midpoint is y of A plus y of G divided by 2. Our midpoint has got a y value of 7 over 2. So I'm going to write that 7 over 2 equals to the y value of A. We don't know what that is, but we do know that the y value of G is actually 2 divided by 2. If you simplify this by doubling both sides, you end up with 7 is y of A plus 2. Then you will have 5 as the y coordinate of A. Therefore, the A coordinates are exactly what they wanted us to get there, which is the point 2 is to 5. We are going to get a value of 2 and a value of 5. The last part of this is asking us to prove that this line that you are looking at here is parallel to this one. Remember, we got that the coordinates here is it 2 and 5? Yes, we did indeed get 2 and 5, so which I'm going to write here as 2 and 5. Now, we know the coordinates of B. We also know the coordinates of A. We want to prove that this line is parallel to this. Now, it's important for you to understand geometry is connected. Whatever you do in Euclidean geometry can work a lot in analytical geometry. So in my mind, the back of my mind, I'm thinking, I already have one part as the midpoint. Can't I use the midpoint theorem to try and figure out the solution? Let's see what will happen if I drag that into this. The x value of this point is not known. We don't know what the x value of E is, but we know that the y value of E equals 0. Now, if I apply a reverse midpoint, look at this. The y value of E is given to us as 0 because it lies on the x-axis. But if I try to use the y value of the midpoint of the point A and B, I will have to add the y value of A plus the y value of the point B and divide them by 2. So what I'm getting here is I will have 5 plus negative 5 all over 2, which is going to give me 0 over 2, which is 0. Now, if you look here, the y value of E comes out the same as the y value of the midpoint. Since this is the point, it does mean that point E is the midpoint of the line AB. I don't even need to work out the corresponding x value. Those two are enough. If the y value of E is the y value of the midpoint, then the x coordinate is also going to be the same thing because those lie on the same line. That then means that since E is the midpoint, we can simply say, applying the midpoint formula here, E is the midpoint, F is the midpoint, therefore EF is parallel to BG because of reverse the midpoint theorem. Very powerful question indeed. Thank you very much for that question. It was indeed a nice question that helps us to apply our analytical geometry and integrate with other concepts of geometry. We're still coming back with a lot of very awesome content. Don't go anywhere. Do stay with us. We'll be back after this.